And what you're going to do for this lecture is you're going to go in and look at the Rotational Dynamics 1, Chapter 8, and then after you've viewed that information, you will then pull up, well, you're looking at this particular video right now, and so this is the problem set that you will be going through. So it says rotation about a fixed axis. Starting a propeller-driven airplane is one problem, and rotation of a cylinder from a falling block is another problem. If we take a look at the first problem, if an engine of an airplane is specified to have a torque of 65 Newton meters, and this engine drives a 2.1 meter long propeller that weighs 400 newtons, how long will it take the propeller to reach 210 revolutions per minute? Okay, so this problem involves torque, it involves angular a moment of inertia, and calculating angular acceleration. You know the angular velocity from 0 to this final 210, which you have to convert to radians per second, and then finally calculate the time. How long will it take, the time it takes, because you know the angular acceleration and you know the final angular speed. You can find the time it takes. So you will need to look in Chapter 7 under definitions that relate to angular acceleration and angular velocity. Okay. The second problem involves again rotation, but here we have a cylinder. This cylinder is going to rotate about an axis through its center as a result of this falling block, which is attached to a string, and as the string unwraps, I know I didn't show very much of the string here, but imagine the string is wrapped around the cylinder, and that unwraps and rotates the cylinder as the mass falls to the floor. So we're told a 2 kilogram block, 3/4 kilogram cylinder, 5 centimeters in diameter. That information allows us to calculate the moment of inertia of the cylinder, and then we can use Newton's law, F equals ma, to express the force and mass and acceleration relationship for the falling mass, and then we could use torque equals moment of inertia times angular acceleration, which is Newton's rotational motion law for the cylinder. And again, we want to know how long will it take the block to reach the floor if it's initially 1.2 meters above the floor. So you'll submit those